Factoring polynomials. In a way, factoring polynomials is undoing multiplication. You'll take a larger degree polynomial and break it into smaller degree polynomials. It's basically undoing the multiplication, except without looking at it from a division perspective. Okay, now you should already know how to factor certain type of quadratics. We're going to work under that assumption. In this set of notes, you will learn techniques for factoring higher degree polynomials, like cubes and quartics or quintic. Okay, different things that are actually capable of factoring them. Not everything is factorable. We should make that statement at the beginning. Okay, for example 1, what I want to address is what a lot of people forget about. And if you ever get stuck when you're factoring, like you're looking at a problem and you just can't figure out what to do, you probably forgot to do this, which is to look for a GCF, a greatest common factor. Is there anything that all of the terms have in common that we can divide out, move to the front of the whole thing? Because if you can, the remaining part might be something that you recognize and can factor. All right, so for the first, each of these has an x in it. They at least have one x because you have an x over here. You don't have a constant term. So you can factor out. It's like dividing, but you're going to factor out because you're keeping the x. Okay? You can factor out an x and move it to the front. You'll just write x, open parentheses, and take an x from everything. Okay, take an x from here. Take an x. Take the x that we got at the end. And when you do that, you end up with a quadratic in here that you may know how to factor. Okay, what are two numbers that would multiply to give you negative 15 that when added together give you a 2? Okay, to get a negative 15, one would be positive, one would be negative. Okay, we're looking at 3 and 5 because they'll have a difference of 2. Okay, so this is going to be x plus 5. The larger is going to be the positive to maintain it here. And x minus 3. And that's it factored. All right, for the second, we've got all the way to the 5th power here. You've even got y to the 3rd power. Okay, so between the two of those, you can factor out a y cubed. You can take all that out. In addition to that, you can also divide out a 2. So we're going to take a 2, y cubed. We're going to factor that from both of the terms. That is going to leave you with a y squared. You're going to have a minus. You lose all the y's here, divide by 2, and you get 9. And what reveals itself is the difference of squares. And the difference of squares is created using conjugates. Okay, so this is going to be 2y cubed times y plus 3 times y minus 3. Example 2 is a polynomial that you don't run into very often. What it represents is a higher degree polynomial with more than 3 terms and also having an even number of terms. Okay, so we got a cubic polynomial. We're skilled in how to factor quadratics. Once we move out of the quadratics, they become a little bit more difficult. Okay, so what you might want to look at here first would be, since it's cubic, is if everything had an x in it and you could factor that out, drop it down to a quadratic. But you can't because you've got that constant at the end, the 48. Okay, so when these show up, if they're designed to be factorable, a technique that you can use is called factoring by parts, also called factoring by grouping. And what you do here is you split your polynomial into 2 parts. You'll have a first half and a second half. It is also important that it is in standard form, that the exponents are decreasing down the line. Okay, now for the first 2 terms, you're going to look for their GCF, which in this case would be x squared. And it becomes that. And then if everything's going to work, if this is actually going to work out, we're going to be able to factor out a GCF here so that it leaves behind the same thing that the other one left behind. Okay, and what we can divide out here would be negative 16. Okay, positive 48 divided by negative 16 is going to give you that negative 3. All right, and then here's the real confusing part of what we look at. Most people don't really talk about it, but what we do is imagine the whole thing is contained in another set of parentheses, or brackets in this case. And you've got 2 big terms. And those 2 big terms both have that binomial as a factor. So in a way, we can do a GCF here we can factor out what they have in common, which is going to be that x minus 3. So I'm going to move that outside of the brackets. Okay, so I'm taking it from here and here. That's going to leave behind an x squared minus 16. And this, again, is the difference of squares. They pop up a lot. So we can continue to factor, get some conjugates here, x plus 4, x minus 4. Some higher degree polynomials can be treated like quadratics. As mentioned before, we are skilled in how to work with quadratics. If we can make higher degree polynomials look like quadratics, if we think of them as quadratics, we can begin to factor them. All right, for example 3, I'm going to suggest that you substitute in a different variable here. Okay, we're going to use a y. We're going to let y represent x squared. Okay, what we've got in our problem is x to the 4th power. Okay, now x to the 4th power is the same thing as x squared times x squared. So if I let y represent x squared temporarily, I could rewrite x to the 4th power as y times y, which is y squared. So it looks like this. Then it becomes a perfect match for the difference of squares. You've got 16, which is 4 squared. Of course, you got the y squared, and you've got 81, which is going to be 9 squared, with the subtraction in between them. So this would factor into 4y plus 9 times 4y minus 9. Of course, we don't actually have y's here. What we really have are x squareds. So as soon as I do that, I'm just going to substitute that back in. We got 4x squared plus 9 and 4x squared minus 9. And this is also the difference of squares. That is the difference of squares again, which is going to factor into 2x plus 3 times 2x minus 3. Okay, now make a special note about this. This is the sum of squares. You cannot factor that. At least you can't factor that with real numbers. So that will stay as it is. Everything about it looks like you should be able to factor it. Okay, and you might attempt to do the same thing that we got here, but with 2 additions. But of course, that would be a binomial squared, which would create a third term. Okay, so make a special note here. The difference of squares factors into conjugates. The sum of squares is a dead end. Example 4, take a look at what we got here. We got 2p to the 8th power. You've got p to the 5th and a p squared. Okay, now we're going to use a similar technique as we did in 3. We're going to treat it like a quadratic. But you might look at this right now and say, I'm not really sure how we're going to do that. Okay, something that might hold you back in the problem is what we addressed at the very beginning of this video, which is to look for a GCF. What do all of these have in common that you can divide out? And that would definitely be p squared. You can take a p squared from all of them. But in addition to that, you can also divide out this 2 because everything is even. So we can factor out 2p squared. And that'll just sort of hang out in the problem all the way to the end. Okay, now if we divide that out, we're going to get p to the 6 plus 5p cubed plus 6. And what I'm going to temporarily do is let y represent p to the 3rd power. Because p to the 6th would just be p cubed times p cubed. So I get to replace that with a y squared. And this gets to be replaced with a y. Okay, so I'm going to leave this b. This will be y squared plus 5y plus 6. And when we're done factoring, we'll fix up all those y's. All right, so what multiplies to give us 6 and adds to give us 5? 2 and 3. So you get 2p squared, you've got y plus 3, you've got y plus 2. But y is not actually y, it is actually p cubed, so 2p squared, p cubed plus 3, p cubed plus 2. And these don't factor any further. We don't have any techniques for that. All right, and last we got my favorite one here, the sum and the difference of cubes. The sum and difference of cubes. Okay, we got a cubed plus b cubed. We also have a cubed minus b cubed. Okay, reference to something earlier. The difference of squares, if the exponents have been 2, you can factor that. The sum of squares, you can't factor. Yet, the sum of cubes, a cubed plus b cubed, does factor. You can actually do that one. Okay, when these factor, this is the template that they're going to become. We're not going to completely break it down why it becomes that template, but it is the template and you want to memorize it. Okay, so first what I want to do is identify the overall structure that we have. You end up with a binomial and a trinomial. Those are the two pieces. That trinomial will not factor any further. If it could, then this wouldn't be our template. So this is it. If you can get all of your numbers in the correct places, with the correct signs, with the correct powers, then you're good. Okay, the way that I teach this for students to memorize is to use the acronym SOAP. The S is going to stand for same. The O is going to be opposite. The AP is going to go together as always positive. Okay, and now what that's going to refer to is going to be the operations. If you start with a sum, your first operation is going to be the same, which means you'll get addition here. Your second operation is going to be the opposite, so that shows up as a minus. Your third will always be positive. Both of these are positive. If you start with a minus, you're going to have a minus here for same. You'll have the opposite as positive, then you will always have positive here. Okay, so let's look at factoring one of these. We've got x cubed plus 64. Okay, obviously x cubed is x to the third power. The root of this is x. 64 is a perfect cube. Sometimes we see it as a perfect square with 8 times 8, but it is a perfect cube. It's 4 to the third power. All right, so as my first step, what I like to do is just to write these down. Because the 64, you're not going to use that ever again in the problem. Okay, it's going to be all about the 4. Right, you're going to get a binomial times a trinomial. In the binomial, you're going to write down those two things. That is your A and that is your B. You got X and you got 4. We'll come back to the sign. Over here, you're going to have an A squared at the front, B squared at the back. So you've got an X squared, 4 squared is 16. Again, I don't want to be looking at the 64, so I wrote down the 4. The middle is going to be A and B together. The X and the 4, which would be better written as 4x. Once you have that, you can use SOAP. It started with a positive, it's the same. You then have opposite, always positive. And that's it. It does not factor any further from here.
Later, blah.